Oh boy, I've really done it this time. I am recording this post commentary rather late. It is right now 11:47 p.m., which, judging by the runtime, is an hour. I won't be done until 12:47 a.m. Why am I decided? Why have I decided to do this so late? Well, you know the drill by now. I really don't want to go through my school material, but I have to, because my midterm's coming up. Literally in days. Not even a week from now, in days. Yeah, I am screwed. But oh, I can hear the sound. I should turn that off. I don't know if the mic picked that up. Okay, so let's continue. We left off on slide 7 last time. Okay. So there's a pretty nasty diagram here of rust at the bottom of a water heater. Did we say leaking? Literally, that's the first sentence on this slide. Did we say leaking? Question mark. Rusted oil heater at bottom. Ugh. Causes. Water heater tanks eventually rust through. They'll often leak at the bottom first, although leaks can occur anywhere. The supply of fresh water constantly moving through the water heater exposes the tank to a much more hostile environment than a hot water boiler. A boiler recirculates the same water, which becomes almost chemically inert over time. The fresh water flowing through a water heater is chemically active and contains lots of oxygen for corrosion. Water heater life is usually less than the life of a boiler. Implications. A leaking water heater may be simply a nuisance. The water may run over to a floor drain and disappear without any great effect. Serious leaks in water heaters can cause flooding. Obviously, hot water leaking out of the plumbing system will reduce the efficiencies of water heaters. Leaks also reduce the pressure and flow available at fixtures throughout the house. Strategy. Look for leaks around the water heater and at the top and bottom. Be careful with gas-fired water heater. When the burner starts up, there will often be condensation in the combustion chamber running down through the center of the water heater. You may hear or see water droplets at the bottom of the heater. Don't mistake this for leakage. The condensation will typically stop within 5 minutes of the burner starting. Okay, there's a picture of just a water heater. Straight up just a water heater. Here's an older oil water heater. Thanks. Oh, I see a lot of spit just showed up onto my computer. Or not showed up, you know. Another diagram. Leak at the connection of copper with galvanized steel. Identify valve on top of heater, question mark. Yeah, no I will not. Anyways, I look to the side and I see a lot of fire on the screen. What's going on? Gas burner cover and rollout shield. Check to see that the burner cover and heat rollout shield are both present and in good condition. A rusted cover sheet may indicate leakage or condensation. Gas burner cover missing / damaged / rusted. On gas water heaters, the burner is typically concealed behind a door and a flame rollout shield. You'll want to open the door and move the flame rollout shield during your inspection to get a look at the burner in operation and at rest. You won't be able to see much of the burner on FVIR, or Flammable Vapor Ignition Resistant. Water heaters, all of that was bracketed by the way. Water heaters, you know what, I should probably just start over the sentence. You won't be able to see much of the burner on Flammable Vapor Ignition Resistant water heaters that have been common since 2003. I'm thinking, how long ago was 2003? That was 23 years ago. Holy. You know, I saw... I know I'm rambling. You know, earlier today I saw a video that was posted just a couple days ago. Incredibles 2, not a good sequel, 8 years later, and I'm thinking, has it really been 8 years since Incredibles 2? And then I'm like, oh my god, it really has. That movie came out 8 years ago. There is typically only a small observation port. Causes. Let me scroll down so I can read all of this. Okay, causes. A missing burner cover or heat oil rollout shield is an installation or maintenance issue. A damaged burner cover or shield is probably the result of careless handling or working around the water heater. A rusted cover or rollout shield may indicate leakage, condensation, or wet ambient environments. Implications. A burner cover or heat rollout shield will allow the burner to get dirty. It will also allow flames to roll out of the burner in a backdrafting situation. This can be a fire hazard and may damage the controls. If the burner cover or heat rollout shield are damaged, they won't be able to do their job. If one of these is rusted, it probably is not easy to operate, and may not be able to perform its function. Strategy. When you remove the cover and move the flame rollout shield, make sure that both are intact and in good condition. If you see rust on either of these, you might suspect rust on the burner and combustion chamber. Wait, you might suspect rust on the burner and combustion chamber. You must look more closely. Took me a second to really get a grasp on how that sentence was phrased. Working space around water heaters. Adequate space, bracket 24 inches, should be provided around the water heater to allow for servicing and replacement. Doors into these areas should be wide enough to allow for removal of the tank. Inadequate clearance from combustibles. Most water heaters do not have large requirements for combustible clearances. Clearances of less than 6 inches are common. Some gas units only need 1 inch clearance. There does, however, have to be adequate working space, bracket 24 inches commonly, around the heater to service the burner and replace the heater. Doors into closets or rooms with water heaters should be wide enough to allow for removal and replacement. Combustible floors. Most gas and oil water heaters are designed for installation on combustible floors, but not carpeting. You're wise to check with the manufacturers of the common systems in your area. Causes. The cause of inadequate combustible clearance are installation and or storage. Scroll down a little more. Implications. This is a fire hazard and or a service and replacement problem. If someone has built walls around a water heater, the replacement costs are going to be much higher than average. Strategy. Look on the data plate for the required combustible clearances and make sure they are met. Watch for PEX tubing. A controversial topic is whether PEX tubing can be connected directly to a water heater. The answer is yes and no. Some manufacturers, including Zurn, Z-U-R-N, Zurn, say their PEX tubing, it says AN, A-N. I think that's meant to say can, C-A-N. Okay, some manufacturers, including Zurn, say their PEX tubing can be connected directly to a water heater. Many others, including Riho, Vanguard, Aponor, and Apollo, I'm guessing these are names of brands, says it has to be 18 inches away. The UPC, bracket Uniform Plumbing Code, says PEX tubing must be 18 inches away from the water heater. The PEX design guide says the tubing can be connected directly to electric water heaters if the code in manufacturer's instructions allow. The guide says the tubing must be at least 6 inches away from the water heater exhaust vents. The guide also says to yawn. The guy also says manifold should be at least 36 inches above or 18 inches horizontally from the water heater. Poor location. Water heaters in garages. Gas or oil-fired water heaters that are located in a garage must be at least 18 inches above the floor, so that gasoline vapors are not ignited by the pilot or burner. Okay. Poor location. Bedrooms, closets, bathrooms. I feel like it's a real no shit moment when you mention those. Gas or oil-fired water heaters should not be located in sleeping areas, including bedrooms or bedroom closets. We also don't want gas or oil-fired water heaters in closed closets or bathrooms. We're worried about backdrafting appliances killing people in their sleep and about inadequate combustible clearances. Some areas allow direct vent water heaters in these areas because the chance of backdrafting is very small. Wow, I did not expect it to be phrased like that. Garages. We don't want gas or oil-fired water heaters in garages that are less than 18 inches above... that are less than 18 inches above the floor. Actually, it's the burner and or pilot that has to be at least 18 inches above the floor. We don't want gasoline vapors to be ignited by a pilot or burner on the water heater. Mechanical protection from vehicles should also be provided for water heaters in garages. Concrete-filled steel pipes set into the floor are one common way to accomplish this. Causes. Poor locations are an insulation issue. How many shots is that now? Implications. There are safety implications where water heaters are in bedrooms, bathrooms, and closets. Fire and or explosion are the implications where a water heater is not high enough off a garage floor. Damage to the water heater and possibly fire and explosion are issues if the water heater is not mechanically protected. Water damage to the living space is a possibility if there is no drip pan under a water heater above a living space. Alright, next slide. This just shows a water heater in a garage. The water heater is not raised. Yet another slide with so much to read. Low water pressure and flow. Causes. Sludge buildup. Implications. Functional issue. Strategy. Flush the system. Low water pressure and flow. Low pressure and flow on just the hot water plumbing is fairly common. Where the piping is galvanized steel, you can expect the rust to be heavier on the hot water piping and low water pressure on the hot side of it. Where the piping is galvanized steel, you can expect the rust to be heavier on the hot water piping, and the low water pressure on the hot side is not a surprise. The hot water piping arrangement is usually larger than the cold water, so slightly lower pressure may be expected. Causes. There is no obvious reason for low pressure on the hot water side. You might look to the water heater. Occasionally, sludge will build up in the bottom of the tank and will obstruct the dip tube. This will restrict the flow of water through the water heater and result in poor pressure. Causes. There is no obvious reason for low pressure on the hot water side. You might look to the water heater. Occasionally, sludge... Didn't I read this? Oh, I just read the sentence again. Anyways, a partially closed valve will restrict flow. An obstructed dip tube prevents good flow. Implications. The low water pressure and flow reduces the usability of the house plumbing. Strategy. If the water pressure is low for no apparent reason, you might recommend flushing of the water heater through the drain valve. Attaching a hose to the drain and directing it over to a floor drain or outside the building is fairly straightforward. Most people recommend shutting off the heating supply and opening the drain valve until water runs clear. Poor water pressure and flow on larger homes. Some large homes have water service pipes of 1 inch to 1.5 inch in diameter. The pressure and flow in these houses can be affected by residential water heaters, which typically have 3/4 inch connections. Another slide with a lot to read. Baffle collapsed or missing. Baffle bracket turbulator fallen down into burner, affecting burner operations, and that's what the diagram is showing. Baffle collapsed or missing, bracket gas or oil. The baffle or turbulator or turbulator as it is sometimes called, is a stainless steel, bracket typically, helix installed in the flue passage to slow down the gas or oil exhaust products as they move up through the water heater and out toward the vent connector. The longer the exhaust products linger in the water heater, the more heat will be transferred into the water. Causes. The baffles may be dislodged from their resting place, so their support tabs may rust off. Rusted baffles are sometimes removed and not replaced. Implications. The baffle may fall into the burner, affecting burner operation and reducing the efficiency of the system. A missing or displaced baffle will allow exhaust products to move too quickly through the tank. This increases fuel consumption. Give me just a second. Oh, okay. Strategy. When looking into the burner compartment on a gas-fired water heater, make sure that the baffle has not fallen down onto the burner. You may be able to look around the draft hood at the top and see the top of the baffle. Where it is not intact, it may have fallen or may be missing. In an oil-fired water heater, you may find that the baffle has fallen down into the fire pot or refractory. This can sometimes be seen looking in through the viewing port. Alright, temperature/pressure relief valve. Water is incompressible, not incomprehensible. Water is incompressible, and with high temperatures inside a tank, it will become superheated water. Superheated water will release. Superheated water will release tremendous energy when/if exposed to atmospheric pressure. Steam explosion, which can wreck the house. TPR will open and release water when temperature exceeds 210 degrees Fahrenheit or 99 degrees Celsius or 150 psi. Don't test relief valves, as most often they will shut off again and will continue to leak. TPR is a safety device. Or temperature/pressure relief valves. So TPRs do two jobs. They will open and dump water out of the tank if the temperature exceeds 210 degrees Fahrenheit, 99 degrees Celsius, just below boiling. They will also open if the pressure in the tank exceeds 150 psi, the maximum normal operating pressure for a water heater. The temperature/pressure relief valve will have a BTU rating stamped on it. Its rating must be the same as or larger than the BTU rating on the water heater. Anyways, how are we doing in game? Good? Good? I see out the corner of my eye a lot of fighting that I'm doing. And I see this gold Lizalfos is on my ass, along with another one. I don't remember if I fought them, Okay, superheated water. And here's a diagram. Hot water, 300 degrees Fahrenheit or more under high pressure. If this vessel is ruptured, the resulting drop in pressure will cause the superheated water to turn instantaneously into steam with explosive outward force. Hot water boils at 212 degrees Fahrenheit or 100 degrees Celsius. Why does the world need two different measurements for temperature? Just complicates things. With high pressures inside the tank where it can't expand, it is not able to boil. This becomes superheated water. At atmospheric pressure, this liquid water should be steam, and when exposed to atmospheric pressure, it immediately converts to steam. This steam explosion can lift a house from its foundations or send the water heater feet into air. Now, I can understand the water heater may be jumping up, but, can lift a house from its foundations? Wow. I would say that sounds ridiculous, but this is real life. This isn't something in the movies, so it has to be real. It can happen. Lift a house from its foundations. That's a lot of pressure. You know how much pressure you need for that to happen? Anyways. Alright, temperature/pressure relief valve. There is a lot of things labeled on this diagram. Oh boy, I don't even know how I'm gonna tackle this. Let's list some of the specific problems you might find on a temperature-pressure relief system. And, okay, from 1 to 14. 1. Missing relief valve. 2. Undersized relief valve. Bracket BTU rating less than water heater. 3. Missing temperature protection. Bracket pressure relief valve only, no ECO. 4. Poor location for temperature sensor of temperature/pressure relief valve. Bracket must be in top 6 inches of tank. 5. Shutoff valve between the pressure relief valve and the tank are installed in the discharge tube. Bracket not allowed. 6. No discharge tube. Bracket dangerous, may scald people. 7. Discharge tube too short or diameter too small. 8. Discharge tube damaged, kinked, or split. 9. Discharge tube dripping or leaking. 10. Discharge tube capped, threaded at outlet end or rusted closed at the end. 11. Discharge tube combined with other piping such as condensate drain or other temperature/relief TPR valve. 12. Improper material used for discharge tube. The material should be rated for water distribution or a listed and approved manufactured blow-off tube. What a weird way to phrase a sentence. 13. The TPR valve or discharge pipe will not drain by gravity. 14. The discharge pipe is connected directly to the drainage system. Causes. Most of these problems are installation issues. Some of them are maintenance related. If this shows up on the exam, what are the causes? I just gotta remember. Basically all causes are installation issues. Implications. Temperature, pressure relief devices are safety items. If any of these conditions exist, safety may be compromised. Strategy. Check temperature, pressure relief valves, high temperature limits, and pressure relief valves for all of the problems we've listed above. This is equally important on rental water heaters as on owned water heaters. The life safety issues here are significant. Alright, another diagram. We like to see these, not a lot of reading. Alright, so a diagram here. The discharge pipe from the T&P relief valve should run continually downhill until it reaches its discharge location. A situation like this can cause the valve to malfunction. Oh my god. Another diagram. Wow. Capped off TPR. Life safety issue. That's all it says. Another diagram. I keep saying diagram. These are pictures. These are examples. Improper discharge location. You know, the exam, I've had exams before where they show you a picture and you have to identify it just like off the top of your memory. It's like I'm looking at the diagrams now with it telling me what I'm looking at, and I still don't know what I'm looking at. I can't be the only one out there, right? I can't be the only one. Oh, oh yeah, did you see that? I used a Rivali's Gale because it's raining, and what an absolute failure this time as well. Come on, buddy. Come on. You can do it. You can do it. There you go. You got the Korok. Congratulations. Alright, next picture. Next example. Temperature rating for pipe is 100 degrees... What? 180 degrees Fahrenheit. 82 Celsius. And for this TPR is 220 degrees Fahrenheit. 104 Celsius. This is not the proper pipe for this use. Next picture. Reduce line from the hot water discharge. Pipe size should stay constant. Damn. Now we moved on to a slide that has things to read. Hot and cold... What? Hot and cold reserved. No, it doesn't say reserved. It says reversed. Why did I decide to do this past midnight? Hot and cold reversed. Cause installation issue. At this point, I may as well just make that my slogan. Dip tube should be on the cold side. Implication: very little hot water will be available. Strategy: water heater usually stamped. Hard to make conclusions. Wow, what a strategy. Thanks for the strategy. Anyway, so they do... I spoke too soon. They do go more in detail with the strategy here. Strategy: many water heaters have hot and cold connections stamped onto the top of the tank. You can trace the piping to see which pipe is getting into the cold. Wait, is going into the cold. However, you can't make any conclusions based on this. On most water heaters, it's very easy to take the dip tube out of the cold inlet and put it into the hot. Many installers don't do this because it's more convenient, given the orientation of the pipes and the tank. It's best to operate the system and see whether you run out of hot water very quickly. Unless there is a problem with inadequate hot water, the dip tube is probably in the right place. Isolating and drain valves. Check for a cold water isolating valve and inspect for leakage. Check for a drain valve and inspect for leakage and or damage. Alright, no isolating valve. There should be an isolating valve on the cold water inlet in case the tank ruptures and floods. Cause. Say it with me now. This is an installation issue. Implications. If there is no isolating valve, the system can't be turned off in an emergency situation. Additional water damage may occur. Strategy: check that there is an isolating valve on the cold water piping adjacent to the water heater. Okay, and now it says number 2, drain valve problems. Water heaters should have a drain valve at the bottom. The valve may be missing, damaged, or leaking. Causes: you already know. This can be an installation issue, mechanical damage issue, or lack of maintenance issue. Implications: there is no drain valve. It will be difficult to get the sediment out of the bottom of the tank. This affects the efficiency and amount of hot water available. It can also result in noisy tanks. If the valve is damaged, it may not be operable. If the valve is leaking, obviously water damage is a possibility. Strategy: make sure that there is a drain valve and it appears intact. We do not recommend that you open the drain valve. Hot water will be discharged immediately. The other risk is that the valve will not shut off when you close it. Again, you don't want to create a leak. We are only now on slide 27 of 58. We've only gone through 20 slides out of the 50 that we needed to go through. Other water heaters: fan-assisted gas water heaters, dual water heaters, circulating water heaters, high-efficiency gas water heaters. Parallel heaters, installed in parallel rather than series. Each heater does the same amount of work. In series, the upstream tank does most of the work. The pipe lengths running to each heater must be of identical length. A lot to read here as well. Dual water heaters. Domestic water heaters are typically limited to 75 or 80 gallons as a practical matter because of their weight and the need to get them through doors. Some large houses require more hot water than this. There are two common strategies for accomplishing this. 2 water heating zones. 2 separate water heaters can be installed in different parts of the house to serve different plumbing fixtures. The house is essentially zoned from a hot water plumbing standpoint. Parallel heaters. I need to scroll down a little bit for this. Parallel heaters. A more common approach is to install 2 water heaters side by side. The water heaters are installed in parallel rather than series so that each water I don't know why it's written like this. The water heaters are installed in parallel rather than series so that each water heater does an equal amount of work. If the units were installed in series, the downstream water heater would be fed by the upstream tank, so it would rarely kick on. The first water heater would do all the work most of the time. Alright, equal pipe lengths. When water heaters are installed in parallel, the pipe lengths running through each water heater must be identical so that each water heater sees the same amount of water and does the same amount of work. Otherwise, one will wear out much before the other. There are few inspection issues with respect to dual water heaters. Ensure each heater has its own shut-off valve. If they are gas-fired heaters, they should have individual gas shut-off valves as well. Most importantly, both heaters should have independent TPR valves with independent discharge pipes, which should never be tied together. This is a safety issue. Alright, and here's a diagram labeling 2 water heaters side by side. Each heater does the same amount of work when installed in parallel. Another slide with a lot to read. Yay, I just love these. Circulating hot water systems. This system provides constant hot water to fixtures to eliminate the need to flush the cold water in the pipes. More common on larger houses. Additional piping is required as the system requires a return pipe from every fixture. Pumps can be continuous or controlled by an aquastat. Alright, circulating hot water systems. Function. Some large houses have a circulator. Some large houses have circulator pumps to keep the water in the hot water piping hot. To keep the water in the hot water piping hot. This eliminates the wait for hot water when a faucet is turned on first thing in the morning. For example, when the system is idle, the water in the hot water piping cools off. When you flow the first faucet in the morning, the cold water has to be flushed out of the pipe before hot water from the tank will reach the faucet. Yeah, it takes especially long during the winter. A circulating loop keeps all the water in the piping hot and eliminates the need to flush the system of cold water. For people who can't afford to wait 30 or 45 seconds for hot water, this is a necessity. You know, I used to bottle that water, not necessarily bottle it, but I used to like I used to grab like a jug and then pour it into my electric tea kettle, the cold water. You know, in the morning when I turn on the faucet for the hot water, but then like 30 seconds of cold water, I boil that water, you know what I'm saying? Why let it go to waste? Why let it go to waste, right? Anyways, additional piping needed. With the circulating hot water system, it's not enough to run a supply pipe with hot water to each fixture. There has to be a second, bracket, return, pipe that allows the water to be moved in a loop through the hot water system or a bypass fitting placed somewhere. Bracket usually under a lavatory sink far away from the water heater that allows the hot water to flow into the cold water line. Ooh, let me get a sip. Did I really almost say give me a sip? Pump. The electrical operated pump is typically a small capacity unit often installed on the return line of the loop. Some are installed on the hot water heater and others are installed under a sink with a bypass valve. Some pumps are set to run continuously, some work off of a timer, while others are operated by an aquastat. Bracket control device that operates based on water temperature. A cut-in temperature of 110 degrees Fahrenheit, bracket 43 degrees Celsius, and a cutout temperature of 125 degrees Fahrenheit, 52 degrees Celsius is typical. Check valve. The arrangement should include a check valve so that when the pump is at rest, cold water from the inlet pipe cannot flow backwards through the hot water circulation loop, my bad. If the pump is inoperative when we turn on a hot water faucet, we will get water flowing both from the water heater and from the cold water pipe through the return side of the loop. You know, I never understood that. I never really understood how turning a faucet, turning the tap, will signal to the water heater, give me cold water, give me hot water, you know? In my mind, you need some sort of like electrical wiring in there, but then again, it doesn't really look like that's the case. So I don't know. My Neanderthal mind just cannot comprehend the way our world operates. Circulating hot water system. The pump may run continuously or may come on when the aquastat senses a water temperature in the return pipe of less than 110 degrees Fahrenheit, for example. Eliminates 30 to 45 second wait for hot water in the morning. Aquastat controls the need for hot water. A cut-in temperature of 110 degrees Fahrenheit, 43 degrees Celsius, and a cutout temperature of 125 degrees Fahrenheit, 52 degrees Celsius is typical. A check valve arrangement with an aquastat will prevent cold water from the inlet pipe to flow back through the water. Didn't I read this already? Why is this on the next slide? Common problems. Common problems with circulating hot water system. Inoperative. Plumbing system will work, but will not have immediate hot water. Well, tough shit. That's just how the world works. That's just the world we live in and how it works. Leaking can reduce house pressure. Overheating or excess noise or vibration. Premature pump failure. Improper arrangement. Check for check valves and direction. About 20 more minutes. I mean, I already did the dishes tonight, so I'm not missing out on anything besides, you know, going to bed. I did try to nap before dinner, but clearly, just couldn't fall asleep in time. So just as I was drifting off, oh, dinner time. Get your ass up. This is a big chunk to read right here. Fan-assisted or power-vented gas water heaters have become popular in some areas. These are typically used in modern heating systems that don't use chimneys. Where the heating system is sidewall vented or electric, no chimney is needed. It becomes impractical to install or maintain a large chimney for a domestic water heater. If an existing chimney remains in service, it is often too large for the water heater once the furnace or boiler is replaced with a sidewall venting unit. Oversized chimneys are prone to condensation and deterioration. Get rid of the chimney. A common approach is to replace the water heater with a sidewall vented unit. Power vented or fan assisted water heaters can be vented through the sidewall using ABS or PVC piping typically. Not high efficiency. This would lead you to believe that these are high efficiency units. They aren't. Fan-assisted water heaters achieve cool exhaust temperatures in a very different way than condensing furnaces. A fan-assisted water heater draws in large amounts of room air to dilute the exhaust products. Dilute with tons of house air. If you mix 70 degrees Fahrenheit or 21 degrees Celsius room air with 400 degrees Fahrenheit or 204 degrees Celsius exhaust products, you can cool the exhaust products. Power vented water heaters draw in... Wow, what is that? Power vented water heaters draw in 21/2 to 4 times as much room air, like 21/22. What? No. There's supposed to be a space, is it? I don't know what this is even supposed to mean. 20. There's no space, so it says 21/2 to 4 times. What the hell does that mean? But whatever. Power vented water heaters draw in 21/2 to 4 times as much room air as there is exhaust product volume to drop the exhaust air temperature below 200 degrees Fahrenheit or 93 degrees Celsius. This doesn't add to the efficiency of the system in any way, since we are removing air from the house that we've heated to 70 degrees Fahrenheit, 21 degrees Celsius. There's no great inefficiency either when the outdoor temperatures are high, but if we have outdoor temperatures of 30 degrees Fahrenheit or negative 1 degree Celsius, and we throw 70 degrees Fahrenheit or 21 degrees Celsius house air outdoors, you can see that there's an efficiency penalty using a power vented water heater. Alright, added complexity. Power vented water heaters have an exhaust fan that requires electricity, controls, and a safety device. These water heaters are more complex, more expensive, and more prone to failures. Ah, technology, you gotta love it. Automatic ignition systems. Most power vented water heaters have either an intermittent pilot or hot surface ignition for the burner. These units do not typically have a standing pilot. Make sure the blower is on. These water heaters won't operate if the blower is not on. We run the risk of dumping exhaust products into the house and overheating the exhaust piping if the blower is not working. A pressure switch, similar to what we use on mid and high efficiency furnaces, checks to see that the blower is working before the burner is allowed to come on. Did I say burner twice? Checks to see that the blower is working before the burner is allowed to come on. Maybe I read that properly and my brain just didn't process it. Oh, did I miss the Korok that I failed yet? Damn, who would have guessed? I was too busy reading school material that I didn't... maybe I didn't yet. There's a Korok coming up that I failed pretty miserably, and you'll see soon enough if it didn't already pass. In fact, I think it might be this next one. Maybe. I don't know. Power vented water heater. Operating sequence for fan-assisted units. Thermostat call for heat. Fan comes on first. Pressure switch prevents the fan is no. The ignition system activates burner. Flame is sensed and the system operates. The thermostat is satisfied. The burner is shut off. 30 to 60 seconds blower post purge. What the frick does any of that even mean? Alright, here's a picture. Induced draft fan. I don't even know what I'm supposed to look at. Okay, this was not the Korok that I failed. Did I already pass it and I just missed paying attention? No. I think it was this one. I'm pretty sure it was this one. I think. Here, watch this. If this is the one I'm thinking of. Yeah, this is it. Watch this. Watch what happens with this Korok. So it seems like a pretty simple puzzle, right? Nice and easy. Bam! Nice and easy. Oh. Like, what can I say besides thank you, physics engine? Now I gotta come back. Okay, the next picture, induced fan. These are not high efficiency. They allow venting through the side wall by dilution combustion products with large volumes of indoor air. Fan-assisted gas water heaters. Common problems with power vented systems. Inoperative. There will be no hot water. Blower intake obstructed. Pressure switch may not be satisfied and system may be inoperative. Poor venting arrangement. Termination point. Vent size. Inadequate support. Poor blower wiring. Electrical and safety issues. Oh boy, there's a lot to read here. And this is just a diagram. Improper sidewall vent locations. Numbers vary in some areas and circumstances. Check local rules. Should be 4 feet. Canada 3 feet. Below or beside doors, windows, or air inlets and 1 foot above. Should be 3 feet from regulator. Should be more than 1 foot above grade. Should be more than 7 feet above paved public walkway or driveway. And then it says here, other improper locations. Less than 12 inches below soffits, below 18 inches from an inside corner, below 24 inches from an outside corner, below 3 feet, or 6 feet in Canada, above mechanical air inlet if within 10 feet horizontally, less than 12 inches below deck / balcony / porch, bracket must be open on 2 sides. Oof. Venting issues. The vents on power vented water heaters are smaller diameters, typically than conventional water heaters. There are also different materials, bracket PVC or ABS, that do not require any combustible clearances. ABS venting is not permitted in some jurisdictions. Oh, my neck. Canada. S636 piping may be required on new installations. The vents usually terminate outdoors and have the same rules for termination location as other sidewall vented appliances. For example, vents should not terminate, and then there's a small list here, should not terminate within 6 feet of a mechanical air supply inlet, within 3 feet of a gas meter regulator, within 6 feet of a regulator vent outlet, less than 1 foot above grade level or the anticipated snow level, within 1 foot bracket or 3 feet depending on the area of a door or window, within 3 feet of the combustion air inlet of another appliance. Rules will vary depending on the manufacturer's requirements and the local authority. High efficiency gas water heaters. Condensing systems with about 90% efficiency, high recovery rates relative to their tanks, more expensive and more complex. These systems may often be combined systems to provide house heating. See chart on second page of 5.0 for comparisons. No, I will not. Ooh, slide 39 of 58. I don't think I can finish this all today. Yeah, I see there's still a lot, a whole lot, a butt ton to read. Anyways, high efficiency water heaters are very different from power vented or fan assisted water heaters. They may in fact have fans, but they have a very different operating principle. These condensing systems operate at efficiencies of over 90% in some cases and are often used in conjunction with space heating. These systems typically have huge recovery rates relative to their tank capacity. For example, a 34-gallon tank might have a recovery of 125 gallons per hour. The burners on these systems can be as large as 100,000 BTU per hour input, since many are designed to provide domestic hot water and space heating as well. We'll get to the space heating side in a minute, but let's have a look at what these water heaters do that is unconventional. Oh my, what a diagram. High efficiency gas water heaters. This type of system is often connected to a coil in a forced air furnace so that it also provides heat for the house as well as domestic hot water. Condensing units similar to high efficiency gas furnaces. Alright, combination systems. I guess this is the next part. High efficiency water heaters and space heating can be a forced air system using a coil and air handler with ducts, a radiant piping distribution system. When heating the house, supply and return pipes go to a coil inside a duct system and or radiant piping distribution. Because of slow recovery rates, electrical hot water heaters are typically not used. General rules. Output should be 10 to 20 times more than the heat loss of the building. Storage tank capacity should be 30 gallons plus 10 gallons per bedroom. I don't even know what I'm reading anymore. High efficiency water heaters and space heating. High efficiency water heaters, brackets, and some conventional efficiency units heat not only the domestic hot water, but also the home itself. The unit has a very large BTU input capacity, bracket 100,000 BTUs per hour, for example. Potable water is borrowed from the domestic water heater to heat the house. This can be done through a number of systems. Let me scroll down. A forced air system using a coil and air handler, bracket fan, with ducts, a radiant piping distribution system. Heating the house. The water in the house... What? The water in the water heater is always kept hot as usual. The tank has supply and return pipes that go to a coil inside a duct system and or to a radiant piping distribution system. When the house thermostat calls for heat, a pump moves water from the domestic water heater tank into the coil, and in a duct system, or ducted system, air is blown over the hot coil. In a radiant piping system, the tank water is circulated through the radiant piping system. The water, air, wet. I'm losing my mind. The warm air furnace has no burner because the hot water coil is providing all the heat the air needs. Similarly, the hot water radiant piping system has no burner and no boiler because the hot water comes from the domestic water heater. Oh my god, this next slide has so much. Knowing me, I don't know if I can read this in like 4 minutes. I'm not gonna risk it, you know what? It's almost 1 in the morning, I'm not gonna risk it, so we're gonna end here. Slide 43 of 58. You know, this is like the worst time ever for a midterm, because as of right now, excuse me, as of right now, the moment that my midterm is coming up and I gotta read all of this stuff for, well, it's Kalos Tour in Pokemon Go. So if you're asking me why not just study during the day, that's why. I know that's a horrible thing to prioritize first, but god damn it, leave me alone. Alright, so it looks like the Korok I'm going to is probably going to be the last Korok I get for today. Oh, I'm tired. There, let me prove to you how tired I am. You know, I gotta be honest, sometimes, there were some times when I was collecting these Koroks, I'm just like, I don't remember collecting this Korok at all. This is the 3rd time in my life I have collected every Korok in Breath of the Wild. Is it? No. No, this is the 4th time. This is the 4th time in my life I've collected all 900 Koroks in Breath of the Wild. And some of them, I'm just thinking, I don't remember ever collecting this Korok. Like the location I went to collect it, I don't remember going here once to get this Korok. I mean, I know there's 900 of them, and I've done all 900 only 4 times. But still, like, some of the Koroks I have no memory of ever picking up. Oh, never mind. I lied. That was not the last Korok I was going to get for this video. Once again, I hope you guys appreciate how much work I put into these Korok videos. Then again, the amount of work I did here on my Korok videos are child's play compared to, you know, someone like Bread Bears. guess I got one more Korok in me before I end. And I am heading in the wrong direction. No, I came over here to check if there's anything to pick up from these guys. And wow, that wooden chest really blended in. What will I do? Will I be able to climb back up? Or do I have to go down and swim up the waterfall? I was able to climb back up. Gee, I can already guess where this Korok's gonna show up. Obviously, at the very top. Alright, see you next time.